All right, so let's go ahead and move on to type 3, which is where you can have two exponentials. But the catch here is that you are going to be able to write these exponentials with the same base. Okay, so it needs to simplify to a very specific format. Okay, base to the x equals base to the y, okay? Where x and y both have variables in it, right? Now, the idea here is that now they could both have variables or the variable could be in one place, it doesn't matter, but the catch is that you can write both sides of the equation with an exponential with the same base. And I am going to use, think of my PEMDAS, I am going to use that strategy from last class, that last lesson. And I'm going to log base b of both sides. Okay, and because I can rewrite this with the same base, I can use my x inverse property, and it leaves me with x equals y, and I no longer have an exponential. So this is the type of equation we're going to look at. So let's do this by some example. Okay. And keep in mind here, so let's go ahead and start with where the parentheses are, where the variables are. All right, so the first thing I notice is that I have an exponential on both sides of the equation. So I'm going to go ahead and, I'm going to look at my bases. I have 1/2 and 64. So I'm going to start with 2, 4, 8. Right, I'm writing out my powers of 2. Okay, so 1/2 is, there's 2 to the first, is 2 to the -1. Okay, notice that orange box. Okay, I'm just replacing it with an equivalent form, and this existing exponent is just going to stay there. Now 64 is 2, 3, 4, 5, 2 to the 6th. Okay, notice that the base is just being rewritten with the same base. Now that I have the base 2, I'm going to log base 2 of both sides. All right. So as I rewrite this here, I am -1, 3 plus x. Okay, 2 to the 6x. Okay, I can keep that exponent in mind, but what's going to cancel out is inverse property, cancel out, and we end up with -3 minus x equals 6x. And we solve for x. All right, x equals -7/3. Okay, let's do a second example. Let's try 4 to the x plus 3 equals 32. Okay, so I first notice that I have the base of 4 and 32. So again, I'm thinking of my powers of 4. Sorry, I'm actually going to go with 2. Okay, you want to use the smaller number if possible, because if I use 4, I kind of skip over 32. So I want to use 2. There we go. So my base is going to turn into 2 squared, and the exponent's going to stay there. Okay, 32 is going to turn into 2 to the 5th all right? And then I'm going to log base 2 of both sides. When you log base 2 of both sides, you end up with, okay, I can do this, 2x plus 6. I'm just distributing that exponent as I go. Okay, my inverse property tells me, let's go whoosh, pshoo, pshoo. I end up with 2x plus 6 equals 5. And then x equals minus 1/2. All right, so these two pieces are very simple, straightforward examples, okay, where I took the bases and I rewrote them using the same base. Okay, now if you can't get it to be the same base, you might have to try more than one number, right? I suggest trying the smallest number, not 4, but maybe try 2, okay? And then we took the log of both sides and that base canceled out and we're left with just the exponents. Notice as I compare to this first part right here, if I end up with this statement, I know the implication is that the exponents are equal. Okay, so now we're going to up the difficulty just a little bit here. Okay, we're going to look at where we have two exponentials, but we might have some other properties to use in order to manipulate the equation into a more usable format. So let's remember that when we multiply two exponentials, we add their exponents. Similarly, if we divide two exponentials, we subtract their exponents. All right, so I'm going to start with this equation here. 4 times 2 to the x equals 8 to the x. Now, keep in mind your PEMDAS. I cannot multiply 4 and 2 because the exponent comes first. So as I'm looking at this equation, I do notice that I have 1, 2, and a third piece, okay? And I'm going to try to write this with the base of 2 because that's going to allow me to work on these properties. So I'm going to look at this left side and I'm going to try to combine it. So we get 2 squared times 2 to the x. So this side here turns into 2 to the 2 plus x because of my property here. And then I'm just going to leave, okay, the other side is 8. So how do I write 8 as a base 2? That's 8, 2 cubed. Okay, so now I can see that I have the same base on both sides, which means that the exponents are equal. Now, I will still show you the log of both sides because that's technically what we are doing. And I'm log base 2, okay? 2 plus x, 2 to the 3x, and the log base 2 cancels. Okay, we get 2 plus x. Look at those blue boxes. Yes, when you have the same base, you end up solving the exponents equal to each other. Oh, how convenient. Boom. X equals 1. All right, let's go ahead and try maybe one more that's going to use some properties. All right, this one's going to be kind of tricky. Square root of 3 to the x plus 2 power divided by 27 to the x equals 3 to the negative x squared. All right, So I have 1, 2, 3 pieces here. Okay, so that's what I'm looking at, are these 3 pieces. All right, so can I turn this into one exponential on the left and one exponential on the right? Yes. Now, there's 2 ways you could do this. You could take this 27 to the x and you can multiply it to the other side. I'm going to leave it where it is so that I can show you the subtraction property. The first thing I'm looking at is the 3 as my common base. So I'm going to take that root and I'm going to write it as the 1/2 power. Okay. Then I'm going to take the 27 and I'm going to write it as a 3 cubed power. And then I'll just leave this side here. Okay. All right. Now my property says if I divide the same base, check out that, same base, then I subtract the exponents. So I get 1/2 x plus 1 minus 3x. Okay, that's what my property says to do. I would subtract the exponents. Notice here that I now have the same base on both sides. So I have my exponent boxed. And if I log base 3 on both sides, okay. Can I combine terms as I do this? Minus 2.5. Okay, my inverse property tells me that these 2 things cancel. Okay, and I'm left with, I'm going to bring it up here, and I'm going to work from there. Minus 5/2x plus 1 equals negative x squared. Now, I don't like fractions, so I'm actually going to multiply everything by 2. And then I'm going to bring my quadratic over. And then I'm going to factor. And solve. So in this particular case, it appears as though I happen to have 2 solutions. And that's possible. It's because of however the equation solves. So let's take a peek up. Okay, so remember that we have more than one exponential in this equation. And what I'm trying to do is combine the parts so that I have one exponential equal to another. Okay, when I end up with this step, I can log both sides and I end up with just the exponents equal. And then I solve whatever is left. Here I ended up with one solution. So now I'm going to look at this bottom one. I have x's in multiple places. And so I notice that I want to try to combine the exponentials where the variables are in the exponents and turn it into one exponential equal to another. That way, when I log base 3 both sides, it cancels out and I'm left with just the exponents that I'm solving. All right, I'm going to go ahead and show you one last one pretty quick, but I'm not going to explain most of it. This is for you to check yourself. Okay, there we go. Let's just, I see multiple x's and more than one exponential. The only way to combine exponentials is if they have the same base so that you can add the exponents. That's it. That's the only way to combine exponentials. So I can't multiply 81 and 9. I can't divide 27 and 81. I have to turn them into exponentials. Okay, so I have these exponentials. I'm going to log. Nope, I want to combine the left side. Okay, see that? Plus, okay, there are those three exponents. Now I'm ready to log base 3 on both sides. X equals 0 is still an answer. All right.